Hello, my name is Laura Molina and this is my video for project number 3, which is for the thermistor. For the following project, we're going to be focusing on a thermistor and we're going to be using the following image, which is our circuit that you can see on this breadboard on the camera. Now, a thermistor is just using the change in temperature and reflecting that as a change in resistance. We're going to be using the following formula to transform that resistance into temperature. Also, for thermistors, usually how it's the relationship between temperature and resistance is that when our temperature increases, our resistance will also increase. Now, going on, this is a diagram that you can also see reflected on the following code. So how we're getting our temperature is by having this jumper cable that is reading the voltage that we're getting the voltage out, which would be in this diagram. We're getting that voltage and then we're transforming that voltage with the following formula into resistance, which is then being transformed into the log R, which you can see here. And then from there, we're inputting that into our formula for temperature, which would be this one over here, the long one. So based on that, we're using this following formula that is just turning the 5 volts into bits. So we get the 1023 times 5 volts over the V out, which is what we're trying to get. What we're getting from the jumper cable, so from A0. And then based on this formula, we can get log R2, which then is input into the temperature formula for Kelvin. So we're getting a temperature in Kelvin, and then we can use the formula for turning that into Celsius or Fahrenheit, and we can see that being shown in our serial monitor. Now, based on these results, we set up logics for the microprocessors. So at the moment, our temperature is at room temperature, which would be like 77 Fahrenheit, as you can see in the serial monitor. So our LED is green, because based on our code, we say that if our temperature on Fahrenheit is less than 70, we have a red light. But if it's equal to or greater than 70 and equal to or less than 80, it's going to be green, which is what we have right now. And then if it's greater than 80, we're going to have it be blue. So to showcase that this actually works, I am going to touch the thermistor with a little ice so that it can cool down. And that way it's going to be below 70. It's a bit hard. Okay, there we go. So now it's below 70, so we see the red LED turn on. If I were to take it off, it's going to eventually cool down to room temperature, which would be about 70, so now it's back to green. However, if I were to heat up a spoon, or if I were to use my hand, it's gonna heat up and go to green because it's now over 80 degrees Fahrenheit. So, as you can see, this follows the logic of the code, which is also shown in this diagram where our circuit is just following what we have. So if it says like, is it less than 70? No. So next one, and next one, and next one until it meets, until one of the requirements are met. So in this case right now it's at room temperature again, so it's meeting the requirement of it being between 70 and 80 degrees Fahrenheit. So based on that, we have our green LED turned on, and we also tested that it works with that code. And if we kind of go into specifics on the code, it's very basic. We have our set, we have where each stuff is being set. So like red is going to be the cable that goes into the port 11, green for the port 10, blue is for the port 9, and then we have our variable set, which will be R1, and then C1, C2, C3, which is from the formula for the temperature. We are also establishing which cable pertains to what number, and then from there we start the setup where we're defining each output based on that. And here's where we define our formulas. So we're going from the voltage to the resistance to the logs to temperature, and then K and F. On the following, we're showing that we want the serial monitor to show the color LED on based on the following temperature, which is defined here. So serial print is just what's going to be shown in the serial monitor. So here we wanted to show the temperature for Fahrenheit and Celsius, and also say which LED is turning on based on what. So that's why we're using the if. So that's saying that if this is met, this is what's gonna happen. But then if that's not met, then we go to the next one, and so on and so forth, as you can see on the flowing of the in the diagram. And yeah, that's it for my video. Thanks for watching.